Thank you very much, ladies and gentlemen, for joining us for this session on first-of-a-kind experimental cluster based on Intel's many integrated core architecture for highly parallel workloads. I'm Rajesh Agni, Product Marketing Manager, Technical Computing Group at Intel. Along with me are Mike Viltabil, Vice President, Worldwide Sales, Appro International, and Jim Ang, Department Manager, Scalable Computer Architectures, Sandia National Laboratories. So I'll kick it off using the soccer spirit that's out there. Talk about this project, talk about the value proposition that Intel's many integrated core architecture brings to this exercise as well as in general. And then Mike will walk us through Appro's Xtreme-X Supercomputer design. And then Jim will share his team's early experiences with the Intel Mike architecture. We'll make sure we leave 10 to 15 minutes for Q&A at the end. Jim has kindly agreed to field all the hard questions. So let's make sure we take advantage of that. And so with that, let's talk about how we three entities came together. It's exactly 2 years ago that Kurt Skaugen, Vice President and General Manager at that time for DCSG, our data center server group at Intel, that he announced the Intel Mike architecture, okay, in Hamburg, Germany, 2 years ago. And at that time, we started kicking the tires with Knight's Ferry, which is the software development platform. And we did that with our fellow travelers, just using single systems that had Knight's Ferry card in it. Clearly, given the HPC space being one of our primary focus areas, it was really important for Intel to test our architecture in a cluster kind of an environment. And that's where Jim and Sandia National Laboratories came into play, and they expressed interest in deploying such an experimental cluster. And then Appro got involved as the OEM for this first deployment of this architecture. We put into place an MOU, a Memorandum of Understanding, that said, hey, here are our objectives, here's our role across the three players. If you look at the Mike architecture-based products shown there, you have Knight's Ferry card on the left, a software development platform, like I mentioned, PCI Express-based, and then on its right is what is the code name Knight's Corner. That's our first commercial product. You heard Raj Hazra, the General Manager, Vice President for the Technical Computing Group at Intel, announced 2 days ago the branding for the Mike architecture-based products called the Intel Xeon Phi product family. Okay? So there's another branding you will have to sort of take it in your stride. But that kind of a branding announcement at Intel doesn't happen every so often. I believe the last time we did it was when we announced Atom. Okay? And so here we are from Intel showing tremendous commitment on this architecture, on this product family called the Intel Xeon Phi product family. So the first product will be called Intel Xeon Phi coprocessor, okay? Codenamed Knight's Corner. So what Jim and Sandia did was they said, oh, Knight's family. And they picked the name for their first cluster as Arthur, right? The first Knight. So Arthur, you can see the picture there from Jim's team. Arthur was deployed September of last year, and then a pretty compelling demo on CFD, computational fluid dynamics, was shown at SC11 by Jim and his team with help from Professor Woodward out of University of Minnesota. He made a diving catch. It was a very compelling demo shown live based on a subset of the nodes from his cluster. So that was a solid start. And again, that's how we three entities came together for this kind of a collaboration. So, like I mentioned, we'll talk about the Intel Mike architecture. There's a tendency to call it MIC, but it's really MIC, so we prefer to call it Mike. Okay? And like I said, it's the underpinning for this brand name called Intel Xeon Phi coprocessor. People will struggle and say, hey, what the heck do we use? And the way I look at it simply is, if you look at Itanium, for example, just as an example, it was called Intel Itanium processor family. Right? So the family name is the high-arching piece. It's based on Intel's EPIC architecture, explicitly parallel instruction computing. So the name of the family first, architecture second. Same logic here. Again, for Xeon, you could do the same thing. Intel Xeon processor family, x86-64 architecture. Okay? So same logic. It'll take us some time to get into that stride. So let's talk about Intel Xeon processor versus Intel Xeon Phi coprocessor family, or Intel Xeon Phi product family. I think, as we all know and love, I think Xeon clearly has become entrenched as the foundation for HPC. Okay, and it does that by covering a full spectrum of workloads, whether those are serial, parallel, the full gamut. And it does that by providing leading-edge performance and performance per watt through pretty solid energy efficiency through some of the technologies it has built into the Xeon processor. And it does that by focus on pretty superior single-core, single-thread performance, coupled with a moderate number of cores. So that's our Xeon processor. Now, if you look at the Intel Xeon Phi, right, what it does is it delivers performance and performance per watt for highly parallelized compute workloads. Okay, and so it does that by utilizing the higher number of cores, the higher number of threads it has, along with a wider 512 bits wide SIMD engine. Okay, so that's clearly a differentiation it delivers over what we have with Xeon. The one piece that we all firmly believe at Intel is it's the biggest differentiation, the biggest value proposition with this architecture is this piece around common software tools with Xeon. And that's not just us waving our flag, it's our fellow travelers, 100 or so that are engaged with us, who have clearly testified that that's a huge advantage, a huge benefit, because that's what we have been using for the last decade or so, the same set of software tools, and I'll talk about that here in a minute, but that really has empowered, that has enabled our partners, ISVs, customers, name them, to get to their destinations very quickly and efficiently. So what do we mean by common software tools? I think this is a pretty straightforward visual slide in my mind. If you look at what Xeon and Xeon Phi coprocessor have in common is, you start with the operating system. Linux is very well established, right, in HPC. So that's something going for you. If you look at the programming languages, you have those covered. Again, common between both the architectures. If you look at programming models, OpenMP, MPI, name it, again, common. When you look at the tools that the developers have been using on a very pervasive basis, whether it's Parallel Studio or Cluster Studio, it's the same set of tools. Okay? So when it comes to compilers, libraries, debuggers, tuners, you're using the same techniques, the same tools. So you don't have to you don't have to learn something new. You don't have to substantially do surgery to your code. So there's a high source code reuse. You're able to use your applications in a pretty seamless fashion. And again, an easy starting point is this piece here. You have an application that you've been running on Xeon. You take the same source code, have the compiler pointed towards the mic architecture, the coprocessor, and bingo, you have that application that you can run on a system or a cluster that has the mic coprocessor in it. Okay, and so the common software tools capability, that differentiation, we believe, is a tremendous value proposition with this architecture. This is another way to look at it. You've been using a certain source code, certain application, running it through the Intel products, like I mentioned, Parallel Studio XC or Cluster Studio, running it through the compilers, the libraries and such, and you've been able to run it on these Xeon-based systems. Now you can scale that forward, okay? Same source code, run it through the same sort of packages, and then you're now in a position to build and run applications seamlessly on the many-core architecture, the Xeon Phi coprocessor. And so you have a system where you have both Xeon and the mic architecture-based coprocessor side by side running in a pretty straightforward fashion. Now when you go to what's the workhorse of the HPC space, which is clusters, again, you can do the same thing. You're in a position again to run the applications that you've been running on Xeon and be able to run it on a cluster that has both Xeon as well as the Xeon Phi coprocessors. So one single programming model that transcends that whole space, to cover both Xeon and Xeon Phi coprocessor. And Kirk made a very solid point here. I mean, if you look at the volume economics that play there, it becomes a real challenge. And so by doing this, you're avoiding costly detours that you would need to take otherwise by looking at, let's say, GPU-based architectures where you're using a different hardware. Number one, you're using a different programming method. It's different from what you've been using on Xeon. The tools that you're using, right, to find out where the issues are, to tune it, to optimize it, that's again different. So by pursuing a path that based on Xeon and the Xeon Phi coprocessor, we firmly believe you're on a track of volume economics and avoiding costly detours. Now here's another way to look at the capabilities that the Intel mic architecture delivers or brings to this space. Now here's the piece that we have seen emerge over the last few years with the GPU-based model where the serial code is run on the processor, the parallel code is offloaded to the accelerator in the case of GPUs. In the case of the mic architecture or the Xeon Phi, clearly you are in a position to do that, like I mentioned earlier on. And we have developed what we call language extensions for offload or LEO that enable you to do that again in a very seamless fashion and utilize the x86 architecture and be in a position where you get tremendous compute flexibility. Okay? Source code with a few pragmas pointing to mic, and here you are running this offload model in a very elegant, efficient fashion on the Xeon Phi coprocessor. So that's for the offload space. But now if you go shift gears and look at the cluster model space, which is probably the most predominant one, that's where, if you look at the top piece here, the Xeon and mic, the chips, it's a little bit hard to read from back there, but I'll share the message there. So far, you have been running, let's say, the MPI ranks on the Xeon processor, okay, as you do this kind of a cluster model, cluster execution. Now, given the mic architecture is really a coprocessor, it can host applications on its own. And so this model here is saying, just like you were doing what you were with Xeon, you can run the MPI ranks on the mic coprocessor, okay? And that's how you have this homogeneous cluster running, okay? Now, if you look at this piece here, which we believe is really something that we need to pay attention as we go forward and optimize not only, some coprocessor that you're injecting into that system or cluster, but also making sure that the Xeon cores are well utilized. And here, the model is the MPI ranks run both on the Xeon processor as well as the mic coprocessors or the Xeon Phi coprocessors. And that's what we call the heterogeneous cluster model. I think Jim will talk about these models as he has deployed them, his team has deployed them at Sandia. I think the message here is if you look at these two models, it's again the same message. Standard MPI, standard compilers, standard tools, right? So using the industry standard is something Intel believes is the cornerstone of whatever we do. And so you're getting the same advantage, same capability here, allowing you to open up new possibilities. And at the end of the day, we believe it's your code. It should be your choice on how you want to do it. Do it efficiently, do it elegantly. With that said, let's look at the competitive landscape, right? We talked about the capabilities of this architecture, of this Xeon Phi coprocessor. What does it mean? So if you look at this piece here, the offload model that I talked about, yes, the GPU-based space, GPU-based systems, clusters can deliver that offload. But I did talk about the ease with which you can do the same thing with the Intel mic architecture or the Xeon Phi coprocessor. And then when you look at the cluster models that we went over the last couple of slides, you have that capability coming with the Xeon Phi product family, which we don't, or which you don't, with the GPU-based models. Okay, so given the Euro football championship, or as we Americans would call it, Euro soccer championship is on, I would probably classify this as a space where we have an advantage of a few penalty kicks. And here, I think we are clearly 2-0. Okay? in favor of the Mike architecture. So just to wrap it up and then transfer it to my collaborator, Mike, here's our roadmap that we have disclosed publicly. We have been talking about Knight's Ferry over the last 2 years, like I mentioned, since Kirk Skaugen announced this architecture. It is a software development platform. We have been working on that with our fellow travelers. We have shared lots of proof points around it at different public events, very promising. And now the focus is going to shift front and center to Knight's Corner or the Intel Xeon Phi coprocessor. And Diane Bryant, who's our vice president for DCSG, she announced recently that the first commercial product will be in production this year. Okay, so that disclosure, that announcement has been made, which is very promising. It will be based on Intel's leading process technology, the 22 nanometers, which is what we are using today for Ivy Bridge. Okay, so that same leading edge technology will be applied to this architecture. We will have greater than 50 cores on this product. We did announce at SC11 north of 1 teraflops performance on DGEM. 2 days ago, we did announce performance greater than 1 teraflops at a node level for high performance LINPACK. That's another promising development. Like I mentioned, it's not an accelerator, it's a coprocessor where you can offload stuff not only seamlessly, but you can host programs and be able to run it native on the Knight's Corner card or the Xeon Phi product family. It's IP addressable, so it sort of stands out as a node on the network, okay? Unlike the accelerators you have there. I did talk about common source code across Xeon that you've been using so far, as well as the Xeon Phi, and we looked at the capabilities where we are roughly 3-0, from a soccer championship standpoint. And I think then the final message is, this coprocessor, we believe, is programmed, like a computer. It's a node on the network, and clearly, provides a lot of differentiation and value, to our fellow travelers, our end customers. So with that, Dankeschön, thank you, and on to Mike.